Welcome to True Projects. In this video, we are going to explain about the project that is the role of big data analytics in revolutionizing diabetics management and healthcare decision making. So before getting into the execution, first let us understand what is this project about. Healthcare, it is changing really fast because of the technology. Today, hospitals and clinics can collect and store huge amount of patient data, everything from medical history to test results. But with so much information, it becomes hard to make sense of it using old-fashioned methods. That's where big data analytics comes in, and it's a way to look at all this data and find useful patterns or trends that might not be obvious at a first glance. So on top of that, machine learning models, they help computers learn from the data and make predictions like spotting early signs of the disease or suggesting personalized treatments. And tools like Apache Spark make this possible on large scale, allowing healthcare providers to quickly analyze huge data sets and make better, faster decisions for patient care. In short, all these technologies together help doctors and hospitals act smart and more efficient, improving patient health and outcomes. So here, diabetes is a serious condition. So, diabetes is a serious condition that affects millions of people around the world and it interferes with the body's ability to regulate blood sugar, which can lead to serious health problems if not managed properly. Even though we know we have access to a huge amount of healthcare data, traditional ways of analyzing it often that is, it can't quickly find the important patterns or predict who might be at risk. So this is where big data, analytics, and machine learning comes in. So by using these tools, it is possible to study large data sets of diabetes data, spot risk factors early, and make predictions that help doctors to intervene sooner. And these advanced approaches can improve patient care. So this project, it is a smart healthcare platform that uses big data analytics and machine learning based models to support better management of diabetes. It collects and integrates large amount of patient information from multiple sources, allowing the system to work with a wide range of data. So here we are collecting wide range of data, and by analyzing this data, the system, it can cover, that is, it can uncover hidden patterns and identify risk factors that may not be immediately obvious. So these insights help doctors and healthcare providers make more informed decisions, leading to improved patient care, more effective diabetes management. So think of today, it's like, that is, think of today's healthcare data. It's a huge coming from hospitals, clinics, sensors, and so many other sources. Normally, handling such massive and complex information would be overwhelming. But with the powerful tools like Apache Spark, this system can quickly process all the data without slowing down. On top of that, it uses predictive models like logistic regression and other machine learning models to train the models. So here, models like logistic regression have been used to train the model so that it will be able to detect the diabetes priorly before taking the treatment. So the person will understand what treatment has to be taken. And this is done in the Apache Spark environment. So moving on, to further improve the performance of this project, here we are incorporating principal component analysis technique, which is a feature selection technique. It is used to pick out the most important points, and PCA turns out to be the best. So these selected features were then used to train the random forest decision tree models. So by using this, the system is able to predict diabetes more accurately, and this shows that choosing the right features from the right data, that is the data, can significantly improve the performances of machine learning models. And here we have developed a user-friendly interface which is created by using Flash framework, where users will be able to provide input in the front end and they can log in securely. Only the registered users will be able to use the system and they can get the predictions. And to implement this project, we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented the project. First, we have imported all the necessary Python libraries, and Spark libraries are imported to handle data processing, visualization, and model training. Then we initialize Spark session, where Spark session is created to enable large-scale data processing and to use Spark ML's capabilities. Then comes data collection. So here, at this stage, the CD's BRFSS diabetic dataset is downloaded from the Kaggle and the dataset is loaded into the Spark environment for analysis. Then comes data exploration and visualization. So here dataset dimensions and descriptive statistics are displayed. Distributions of the dataset columns are visualized to understand patterns and relationships among the variables are explored and correlation heat maps are generated to identify strongly correlated features. Then we do data pre-processing. We split the data into training and testing. Then we train all the machine learning models and they are evaluated using accuracy, precision, recall, and FN score, and we will be saving the best performing model. Then comes model deployment. And here in the front end part, where we will be integrating Flask framework to develop a web application where users will be able to register as well as login. And they provide the input test data that will be pre-processed and it will be fed to the trained model. Trained model will be giving us a prediction. Coming to the algorithms used, these are the algorithms used in this project. And requirements to implement this project, basically we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So let's open it. So here we have the code folder. So let's open this folder. So let's understand what are these files first. So in this folder, we have the data set. This is the 2015 diabetes data set, which is used in this project. It's opening. Just wait for a while. Until then, let's check with the other files. So get back. And this is the static folder in which we have files related to CSS, JavaScript, and Bootstrap files, which are important for the project's visual appeal. And here we have templates folder in which we have files that are HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have Jupyter Notebook file. So this Jupyter Notebook file, it contains a combination of code, graphs, and outputs all in one place, and it allows users to write and execute code in individual cells. Here we have main.py file. So this file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have the other Jupyter Notebook file. This is the Windows batch file. So instead of executing this project through command line interface, we have created it. So here we have database file, which is used to store the user information. And the dataset is also open. So this is the dataset that we have used in this project. And here we have different attributes based on which we will be predicting the diabetes. So let's close this and double click on this run flash file. Click on run. Now main.py file will be compiled and this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app, that is main.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So here you can see Spark session has been initialized. So let's wait for a while. So this is the address where application has been hosted. So copy this local link provided by the Flask framework and paste it into any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. Paste the link here and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get registered first. So click on register and enter all the details to create an account. I have already created account, so I'll directly log in. Click on login. So provide your username and the password. Click on login. We have logged in successfully and redirected to prediction page of this project. So here we have multiple options. So you can either click on start prediction, you can either click on start analysis, or you can either click on predict diabetes healthcare. So let's click on start prediction. And here you need to upload a file. So before uploading, ensure that it is in the format of CSV file. So let's click on choose file. Select the test data, click on open and click on analyze my data. So this given file, it will be pre-processed at the backend. It will be fed to the trained model and the trained model will be giving us a prediction. And here you can see prediction is completed. And here we can see there are total 10 cases were given, where normal cases are 4, diabetic cases are 6, and the model accuracy is 95%. So for the first case that we have given, we have prediction that it is diabetic. For the second case, it is predicting diabetic. Similarly, for the third case, normal. For fourth case, normal. And then diabetic, diabetic, normal, normal, and diabetic, diabetic. So in this way, from all the cases given, 4 cases are classified as normal and 6 cases are diabetic cases. And we have model accuracy of 95%. Now let's check with the data visualization. So click on it. So here we have the graphs. The first graph, it shows the cholesterol check. So each color represents one person, and here we have gender, where this blue represents male and orange represents female. And here we have correlation matrix. Here we have accuracy comparison graph, where on x-axis we have all the models that we have trained, and on y-axis we have accuracy score. Moving on, here we have accuracy comparison graph of the extension model after applying PCA for random forest and decision tree. So you can even print the visualizations that we have. Now click on log out. So in this way, just by giving inputs to the application will be accurately predicting the diabetes by using both big data as well as machine learning. So the power of data was used to make healthcare smarter and more effective. By looking at the patterns, large amount of health information, the system can help in identifying people at risk of the diabetes early and provide guidance for better care. So with an easy to use interface, anyone can interact with the system and get predictions, making healthcare more personalized, accessible. And overall, this project shows how technology can turn complex health data into meaningful insights, helping doctors make better decisions and ultimately improving people's lives. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.